Well, hey guys, I am continuing these problem sets that I phrase as being unusual ACT math questions. Really, they're questions that were more conceptual than the others on the test. And most of the time you find these particular exam questions between number 30 and number 60 of the ACT math exam. And I've selected these because many of the students that are personally trained have missed these predominantly. And so I'm really wondering if that's what's happening across the country. I bet it is. Now, I hope that this will help you. And by the way, these questions are coming off of the April 2017 exam. And if you have it, and let's say you're preparing with it, maybe one of these questions that I'm going to review will help you. Most importantly, pay attention to the logic about solving these particular problems, because that's where you're going to get the most help. All right, first question. Which of the following expressions, when evaluated, equals an irrational number? Okay, so you got to know the difference between irrational. Let me get my pen set up. Pardon me. You got to know the difference between irrational and rational. So rational, we're talking about numbers that are like 2, 8 divided by 4, which is equal to 2. 1/2 is equal to 0.5. Terminating decimals. Irrational numbers are like pi, or a decimal number that would be like 4.23672, and it continues. Okay, with that in mind, we've defined those two terms. Which one of these answer choices equals an irrational number? The easiest thing for you to do here is to take your calculator and do the math on each one of those. So F, I'm not going to do the longhand mathematics of rationalizing the denominator, but when you use your calculator and you take the square root of 2 divided by the square root of 8, you get 0.5. So that's rational. G, the square root of 8 divided by the square root of 2, you get 2. H, when you square a root, you cancel it, so therefore H is 8. Okay, J, the square root of 2 times the square root of 8 is the same thing as the square root of 16, which is going to give you 4. So all of these numbers here are rational. Now K, the square root of 2 plus the square root of 8 ends up giving you a decimal equivalent of something of 4.24264, and it continues. So here is our irrational answer choice, which is K. Okay, let's move to the next question. So a line through the origin and the point 10,4 is shown on the graph. The acute angle between the line and the positive x-axis has a measure of theta. What is the value of the tangent? Okay, so here, the first thing that you need to do is drop a line from here to here. That gives us a right triangle. Always drop your points to the x-axis. So we got a right triangle. And with that being said, let me change my pen color. So here's what we have. Make it just a little bit bigger, like so. Got the point here. You know that's 10, 4. Here's y, here's x. Drop this straight down, and you know that comes here to number 10. There's our right angle. So the distance from here to here, with this being the origin, 0, 0, is 4. And this side of this triangle is 10. Now, theta is drawn right here. So we're looking at the triangle from this standpoint. So this side is the opposite. This side is the adjacent. And of course, across from the right angle, you have the hypotenuse. Now the tangent formula is opposite over adjacent. Well, the opposite is 4. The adjacent's 10. That can reduce by 2, and it gives you 2/5, which would be answer choice D as in dog. I think the most important thing here is just to remember, when you're given a point on a line and you just got a terminal line, drop the point to the x-axis, not the y-axis. Drop it to the x-axis. All right, let's move on. This is an interesting question. A lot of people don't think about the absolute value of x being negative. And you can force it to be negative, and I'm going to show you how. Well, everybody knows that the absolute value of some number, whether it's negative or positive, right, is always going to be positive. But we can force the absolute value of x to be negative if we put a negative sign outside of the bars. So in this case, no matter what the number is in these bars, it's always going to be negative. So there's the way you force absolute value to be negative. Why is that important to this question? Well, let's read it and you'll see. The equation absolute value 2x minus 8 plus 3 is equal to 5. It has 2 solutions. Well, if it has 2 solutions, it has 1x, right? That means we got to play with making the equation negative, like I've shown you here with the absolute value of x having the negative sign outside of the bars. So we're going to write our equation in such a fashion that it models what I have here. So the absolute value of 2x minus 8 plus 3 is equal to 5. Now we can rewrite it this way, the positive way, and we'll have a 2x minus 8 plus 3 is equal to 5. Look at your answer choices. F has 2x minus 5 is equal to 5. G has 2x minus 8 is equal to 2. Well, where does the 2 come from? Well, right here. We can move the 3. We can subtract the 3 from both sides. And we get 2x minus 8 is equal to 5 minus 3, which is 2. So 2x minus 8 is equal to 2. So there's one of our equations. Now we can do the same thing over here. We're going to look at it from a negative standpoint. Over here was from the positive standpoint. So we can rewrite this by putting a negative sign on the outside of the absolute value bars. And I'm going to replace them with the parentheses here. So 2x minus 8, put a negative sign on the outside, plus 3 is equal to 5. Well, subtract your 3 over, and then we get a negative 2x. Sorry, let me make that more round. Minus 8 is equal to 5 minus 3, which is equal to 2. Now, look at your answer choices. Look at K. K has 2x minus 8 is equal to 2, so it has this one. And it has the negative binomial 2x minus 8 is equal to 2, so it has that one. So it's answer choice K. You see, it's the logic. It's the logic about how you can manipulate the math. Most people look at this and they think, oh, this will be really easy, but not necessarily. Let's move on. Alrighty. So we have this particular question, which says the graph of the function y is equal to f of x consists of 3 line segments. The graph and the coordinates of the endpoints of the 3 line segments are shown in the standard plane below. What is the area in square coordinate units of the region bounded by the graph of y is equal to f of x, the positive y-axis, and the positive x-axis? So I'm just going to redraw this up here. Let me get rid of that drop-down box. All right. We got something right here. It goes like this. Then we got a line that goes straight across, just a little. And then we got a line that comes straight down like that. They tell us this is 5, 0, 3, 3. They tell us this is 2, 3. I'm going to put it up here. And they tell us this is 0, 4. We need the area beneath the line, bounded by the y-axis and the x-axis. So look for geometric figures that will be on the ACT. Look for them becoming evident in this particular problem. Well, let me show you what I mean. So from here to here, we can drop a line straight down. And we create a right triangle. Well, over here, we can create another triangle. We got another right triangle. Now, how do we get the links of these triangles in this, what looks like to be a rectangle, but it's not going to be a rectangle? We're going to find out I think it's a square. So if we're at 4 on the y-axis, right? And we're at the y value here of 3, then the distance here is 1. And we know here we have an x value of 2, so this is 2. Coming to the bigger triangle, the y value in our coordinate pair is 3, so this side's 3. Now, the x value is also 3, so right here on the x-axis, we have 3. Well, right here on the x-axis, we have 5, so 5 minus 3 makes this side of the triangle 2. Well, let's take this big rectangle looking figure and see if it really is a rectangle. Well, here's the origin. This is 0. So from 0 to 3 is 3. And then we know the other side of it is 3. So it's 3, 3, 3 all the way around. So it's really a square. Now, let's take the area of the large triangle, T sub L. That's 1/2. base times height. Okay, 1/2, 3 times 2. 6 divided by 2 is equal to 3. So that area of the larger triangle is 3 units. Okay, let's do the area of the small triangle. Same equation. So it's 1/2 times 2 times 1. So 2 divided by 2, that's going to be equal to 1. So the small triangle is an area of 1. Now we can do the square. Well, the area of a square, I'll put SQ, is equal to the side squared. Well, the side is just 3, so therefore it's 9. Now we know the area of each one of those. Let's add them all up. 9 plus 3 plus 1 is equal to 13. So the area beneath the curve is answer choice B, 13. 13 units. All righty. Moving on to the next one. The list of the numbers 41, 35, 30, X, Y, 15 has a median of 25. The mode of the list is 15. To the nearest whole number, what is the mean of the list? Okay, so first thing you need to make sure you understand the difference is mean, median, and mode. The mean is the average of the set. The median will be the middle number. And the mode is the number that appears most often. Appears the most. Well, let's leverage this set of numbers. You know, when you work with a mean, median, and mode, you're going to have to put these numbers in order. And they tell us the mode of the list is 15. So we have a 15 in the set. They tell us that the mode is 15, so that means we have to have another 15 in the set. Then we have a 30, a 35, and then a 41. And then we have Y left over. So we have some unknown number Y. We need to use this unknown number to our advantage based on knowing the median. Now, to figure out the median, that means you've got to count to the middle. And there's 3 numbers here and 3 numbers here. So that means that we're going to have to, the median has to be the average of 2 numbers. So, the average of 2 numbers produce a 25. What number divided by 2 gives us 25? Well, 50. With that being said, our 2 numbers in the middle have to add up to 50. So we've got 15, 15, 30. Here's one of the middle numbers. Y, 35, and then 41. Now 30 and Y have to add up to 50. So that makes Y 20. So 30 plus 20 is 50, right? 50 divided by 2 is 25, which matches our mode. I mean, our median. I apologize, our median. So now we know our whole set of numbers. What is the mean of this list of numbers? Well, 15 plus 15 plus 30 plus 20. 20 should really be here to do this right. Plus 30 plus 35 plus 41. And we're going to divide that all by 6. And when you do that, you're going to get the number 26. The logic, see how we use the logic to figure out what the value of y would be? It's usually all about the logic. Memorization is about putting the numbers in order, right? Memorization is about knowing the definitions of the mean, median, and mode. But how did we logically deduce that y would end up being 20 is what's important. All right, with that being said, let's move on. Okay, so what we have here is two equations. It says you're given the following system of equations. Y is equal to x squared. Then the other one is Rx. So let me just write it here. Y is equal to x squared. Then we have Rx plus Sy is equal to T. You're given these two equations where R, S, and T are numbers. For which of the following will there be more than one coordinate pair solution with real number coordinates for the system? Okay, so let's try to make some sense out of our system of equations. We know y is equal to x squared, so we can rewrite the second equation by saying Rx plus Sx squared is equal to T. Well, look what we have developing here. We've got a quadratic developing here. T is going to represent some constant. So let's rewrite this, as most people are familiar with writing quadratics, from the highest power to the lowest. So Sx squared plus Rx minus T is equal to 0. Okay. We've got this in proper order now, and it's mimicking a quadratic formula here. Notice our answer choices. Our answer choices are R squared plus 4st is greater than 0. Remember the idea of the discriminant, b squared minus 4ac. Well, when it's greater than 0, you get two solutions. Let's take our letters and replace them into the discriminant. So R is actually the B term. T is actually the C term. And S is actually the A term. So we can rewrite this thing here to say R squared minus 4. And then our A is S, and our C is T. Now we know when the discriminant is greater than 0, we get two solutions. And when we have just rewritten this thing, oh, I forgot one thing. This is a negative sign, so T becomes a negative T. And again, we know when the discriminant is greater than 0, we get two solutions. Now let's clean up this formula down here. So this actually becomes R squared, and we have a -4 times a positive S. That's going to remain negative, and then a negative times a negative makes everything positive. So it's going to be plus 4ST. And the only one that fits what we just deduced here is answer choice F. Okay, the logic again, it's always the logic. Oh, and be careful because I almost messed up and forgot about my signs. So be careful with those signs. And one thing that happens on when you go to take the exam on exam day, you go through all those questions real quick and you're thinking, man, I answered every one of those questions. And then you make a sign error that you're not aware of, just like I almost did here. So please be careful, okay? Please be careful. A lot of the times you're really capable of getting these questions correct, but then you make the little error, the nuisance error of overlooking your signs. Happens all the time, and it's heartbreaking to see. All right, let's move on to the next one. Okay. So our next question we come up with is one of the following graphs in the standard coordinate plane is the graph of the sine squared of x plus cosine squared of x over the domain of -π² all the way to π², where x is between the two. One thing you need to be aware of is the identity. It's really important. So sine squared of x plus cosine squared of x is equal to 1. That 1 is your y value. This is really important. Now, which one of these graphs gives you the value, a y value of 1 from -π² to π²? Well, the only one that does that is answer choice H. Now, for some of you, you perhaps have never seen this identity, sine squared x plus cosine squared x is equal to 1. Most people aren't introduced to this identity until you get into your pre-cal class. So I can't really say this is a real fair question, but it was there. So make sure you memorize this identity, okay? And you can use this identity to solve for the sine or the cosine by simply solving the equation for the sine by taking the square root. Let me just show you what I mean by that. Let's say I want to figure out what the sine is. So I would say sine squared of x is equal to 1 minus the cosine squared of x. I want to take the square root of both sides, and this would give me the sine is equal to 1 minus the cosine squared of x. That's a side note. I'm just thinking in the future for what you might run across. And I'm trying to help eliminate two birds with one stone since we're already looking at the identity here. Okay. Now, let's move on. What is the period of the function f of x is equal to cosecant of 4x? Okay. This relies on you knowing information about the sine, the cosine, and the tangent, their periods from the parent function. The parent function sine of x, its period goes through 2 pi, the parent function. The cosine of x period goes through 2 pi. The tangent parent period is simply pi. I'm not going to carry you through drawing each one of these graphs. You can memorize this. Now there's a formula that you can use as well. Period of the parent divided by the coefficient of x. The coefficient in this function is 4. So we're going to divide it by 4. The period of the parent for the cosecant, which is the sine, is 2 pi. Now, you can reduce 2/4 to 1/2 or pi over 2, and therefore answer choice E. Again, kind of like the trigonomic identity that I showed you just a minute ago, sine squared of x plus cosine squared of x is equal to 1. You may or may not run into this type of problem if you're in Algebra 2. It just depends on how in-depth your Algebra 2 class is. I'm not going to get into all the prerequisites that you really need to have to do really well on the ACT math test and or the SAT math test, but there are some trigonomic identities that really are helpful to know. Now, let's go on to the next question. So this is a neat question. In the note, they tell you how to solve it. Most people overlook the note and don't follow the instructions. So for what positive real value of k, if any, is the determinant of the matrix? So here's the matrix they give us. We're going to look for the determinant, k, 3, 4, k. What positive real value of k, if any, is the determinant of the matrix equal to k? In the note, it tells you the determinant of the matrix. I'm going to put it over here. A, C, B, D. The determinant of the matrix is equal to this formula, A times D minus B times C. Now look where your terms are at the top of the screen. K3, 4K. So K is the A, 3 is the C. 4 is the B, and K is the D. Well, let's just do what it says. A times D minus B times C. So A is a K, D is a K. Now B is a 4, and C is a 3. K times K, K squared. Negative 4 times 3, minus 12. Now, we got to finish this because the question says equal to K. See the quadratic equation developing? K squared minus K minus 12 is equal to 0. You can factor this. When you factor this thing, we're going to have K and K. 4 times 3 is 12, and 4 minus 3 gives us 1. So we're going to have 4 and a 3. Now, notice our signs are negative here, right? So we're going to have a negative and a positive. We need the 4 to be negative because the middle term is negative. So therefore, K will be equal to 4, or K will be equal to negative 3. Which one of these solutions did they put in our answers? They put K is equal to 4, so B. Now they also put 3, but positive 3 is not one of our solutions. It's negative 3. So if you made a sign error here factoring the equation, then you are caught in a conundrum. Okay. I think we got one more question. Yeah, one more question. For the angle being between negative pi halves and pi halves, the absolute value of the sine can be greater than or equal to 1. Now it says, is true for all and only the values of the angle in which of the following sets? So this requires you to really understand some things about the sine wave. Okay, so if this is negative pi halves, I'm going to put it up here. So if that's negative pi halves right there, and this is positive pi halves, I'll put it right here. Then our sine wave, remember our sine wave starts here and it comes up right there, comes down, and it comes back 360 degrees here. Pi halves is right here, which is the same thing as 90 degrees. Now, the sine wave going towards the negative numbers comes down and peaks and then comes back, continues to go. So there is our negative pi halves, and there is our pi halves. Now on the y-axis, remember the parent function here, right here is a -1, and here is a +1. So at pi halves, the part of the sine wave we're looking at is from negative pi halves to pi halves. And at that point, we have -1 and +1. So therefore, the absolute value of that, makes our negative pi halves 1. So therefore, our answer choice has to be answer choice A. All because the equation is talking about the absolute value of the sine. Okay, guys. There are some things that was on this particular math exam that you may not see in Algebra 2. Some of them are really addressed heavily in the pre-cal class. The good thing about it is there are very few questions that have trigonometry from a pre-cal perspective, dealing with the sine and cosine and tangent waveforms on the exam. I hope this helps you, and I wish you all the best in your studies, preparing for the ACT. And if I can ever be of help, please reach out to me. Our contact information is on our YouTube page. You guys have a great day. And thanks for watching.